Hello and welcome to another augmented qubit video. This video has been generated through AI, so please keep this in mind when viewing the content. Now let's get started. If you have been following our series, you would have learned that the clock cycle of quantum devices is slower than that of conventional devices. Despite that, the former processes data faster than the latter. In fact, in one article, a tech writer wrote that quantum devices are 158 million times faster than today's most sophisticated supercomputers. There are other opinions suggesting that the new generation of computers can perform in 4 minutes what conventional devices will do in 10,000 years. Given the importance of ultra-fast speed in computing, does this mean a bleak future for conventional computers? Well, to learn how things will play out, and just how fast are quantum computers? Continue watching this informative piece. Classical computers' processing speed. As you already know, the central processing unit, CPU, or processor of a computer, is also known as its brain. It is designed with lots of transistors in a way that increasing its computational capability will require adding more and more transistors to it. Basically, the processor executes the user's instructions. The strings that the processor manipulates are made up of bits. As you are well aware, conventional digital devices process and store information in binary digits, or bits. The bits create binary codes the machine has to read and understand before executing tasks. Depending on the charge applied to it, the bits could be 0, off, or 1, on. Also, the pair of bits can produce 4 values: 0, 0, 1, 10, and 11. This means that the bits can only exist in either state of on or off, but not at the same time. When the strings get longer, the processor can have up to 3 bits with 8 values. To determine the rate, speed at which the device executes instructions, its clock speed is measured in gigahertz. In other words, gigahertz means billions of simple logic operations per second. Quantum computers' processing speed. Unlike conventional digital devices built with transistors, quantum technology uses qubits for processing data. Qubits are particles that exist simultaneously due to features known as superposition and entanglement. Because the qubit can exist in several forms, quantum devices can perform tasks much faster than their classical counterparts. Given this high speed, data processing in quantum devices is measured in teraflops, trillions of logic operations per second. Processing speed, classical computers versus quantum computers. Having come thus far, let's focus on speed and then discuss some real-world examples. In 2019, tech giant Google disclosed that it has reached quantum supremacy. According to Google, its quantum device can calculate in less than 4 minutes what it takes the world's fastest supercomputer 10,900 years to work out. Giving specific details, the Google team stated that its quantum computer, Sycamore, completed the task in 200 seconds and that it has 53 qubits. The researchers also revealed that Sycamore has Transmon superconducting qubits and refrigerated in a dilution fridge to cool it under 10 millikelvin. Digging deeper into its finer points, Sycamore processes data using microchips and features qubits stored in large components made of gold and copper. In September 2020, D-Wave, the leading quantum tech company, launched its quantum computer known as the Advantage System. The Canadian quantum software development firm stated that the Advantage System is the first of its kind in providing commercial and business solutions. Its press release indicates that the Advantage System has a new processor architecture of 5,000 qubits and 15-way qubit connectivity. With this tech wizardry, the next-gen gadget can tackle their users' most difficult and complex business challenges. To get a sense of what this cutting-edge device brings to the business milieu, the D-Wave team said that the Advantage System can solve complex problems 3 million times faster than today's digital devices. While all this sounds mind-blowing, it is noteworthy that D-Wave does not implement the generic quantum solution. Instead, the firm specializes in quantum annealing, a method of optimizing the solution of a problem, which in this case is business-oriented. Jumping on the bandwagon of quantum supremacy, the IBM quantum team unveiled its ultra-fast quantum computer, Eagle, in 2021. The Eagle has 127 qubits, making it the world's fastest quantum device at time of writing. See the following article for any update to the fastest quantum computer available today. In short, It surpassed China's 113-qubit Zhuzhang, 2i, Google's 72-qubit bristlecone, and IBM's 65-qubit Hummingbird. By arranging the qubits in a single layer, errors are reduced to the barest minimum. With respect to its speed, the Eagle is faster than any conventional device ever known to man. In precise terms, experts estimate that the Eagle can solve in 3 minutes problems that will take conventional devices about 600 million years to tackle. As IBM puts it, the milestone is quantum advantage. The team further claimed that recreating one Eagle's state on a conventional supercomputer would require all the atoms in every human being on planet Earth. Is this the end of the classical computer era? At this juncture, you may just be wondering, will the emergence of quantum computing herald the end of the conventional computing era? In truth, you are not alone. This is because speed means everything in computing. For instance, why would anyone spend 2 weeks doing a task they can complete in a fraction of seconds? Beyond a shadow of doubt, this is what quantum computing brings to the table. However, according to Rebel Brown, VP of Strategy and Marketing at Quantum Computing Inc., QCI, today's digital devices will still be useful in the future. Brown believes that conventional devices will always remain relevant, especially for working out simple calculations and manipulating data with spreadsheets, sending out emails and typing with word processing software. In her view, Brown opined that the next-gen digital gadgets will only augment today's digital devices. That is, with advanced machine learning and artificial intelligence, quantum devices are likely to completely substitute conventional devices where predictive analyses are critical. This is because they can analyze data and accurately predict the outcomes at a breakneck speed. For instance, it will be highly significant in accurately predicting weather patterns and traffic modeling. Indeed, close observations show that there are constantly changing variables in those spectrums. Additionally, quantum technology will also play a pivotal role in mimicking complex chemical and physical processes of nature at atomic level. Plus, they can foster the process of developing new medicines and vaccines and inventing superconducting materials that are capable of conducting electricity without incurring energy losses.